Picking up where we left off with our analysis, now that we've computed the amount of revenue each company makes per employee, we can, for instance, rank these companies by revenue per employee and get a different view compared to what we had before of these companies. So before we were looking at these Fortune 500 companies sorted by the order they were given in the list, which was by total revenue. But when we sort instead by revenue by employee, an interesting pattern kind of emerges. And we notice that the companies that dominate the top of this list are mostly energy companies. ExxonMobil, Shell, BP, and the Chinopec Group. Then there are a number of other companies. We have Toyota and Volkswagen, automobile manufacturers, and then a mix of energy companies, Walmart, of course, being a retail operation, and Berkshire Hathaway. Quite frankly, I don't remember what they do. A holding company. So basically financial services. So as we start to see these patterns emerge, we might get interested in what kind of dynamics drive these companies. How are they shaped by what industries they belong to? And how do they compare to their competitors within their industries? The Fortune 500 company list we're seeing, which was organized by total revenue, is maybe not the most insightful way to think about these companies. So let's do some aggregations by industry and delve into that aspect of the data a little bit. So the first kind of simplest thing we can do is simply to count how many companies we have belonging to each industry in our data. And we see by far petroleum companies are the best represented. So one might conclude that petroleum companies tend to be quite large. They first of all, drilling for oil and refining oil are large industrial practices that requires a lot of expensive equipment and a lot of space. So that's maybe not so surprising. They also either must lease or own the land that they extract oil from. There's a lot of costs. And so it's not so surprising for a list which orders these companies by total revenue that large kind of industrial companies in petroleum, power, and automobiles rank near the top. So this maybe also tells us something about kind of what, depending on what we're interested in about these companies, what sort of biases we might be disposed towards. So since we only have more than one company in petroleum and automobiles, let's turn our attention to those two industries. So here's the slice of our data with the companies in those two industries, automobiles and petroleum. And if we wanted to compare these companies to each other within and across industries, then we're going to have to get a picture of how what the typical scale of these industries are. We've seen that petroleum companies are sort of disproportionately well represented in the data, and are likely operating at a different scale of industry than, for instance, automobile manufacturers. So once again, we're going to scrape some data from Wikipedia to, and if we just visit this page, we can actually see what it is. So we go to the page on the automotive industry, and the particular tables we're interested in are the production, the counts or total production of automobiles in the world year by year, as well as the total production in 2016 for various automakers. So we see Volkswagen and Toyota here near the top. So here are our totals in this car totals variable, where we see in 1997 there were 54 million automobiles produced, while in 1998 there were only just shy of 53 million. And we also have that production by manufacturer. So we have Volkswagen and Toyota, and this was from 2016. Volkswagen made 10 million cars. Toyota made a couple of 100,000 less. And if we care only about, for instance, so here we're picking out the production for the most recent year in the data. So car totals minus 1 gives us 2017, and we were picking out year and production, so the second element would be that production count, 97,302,000, etc. So we'll maybe want to normalize these production numbers, which are kind of meaningless on their own, for each manufacturer, and get a view of their market share. What percentage of the total vehicles produced were produced by these two companies? So we'll create a market share dictionary, and for each company, among Toyota and Volkswagen, we will create an entry in our market share dictionary keyed by the name, and that's going to equal the production for that particular manufacturer divided by the total production. I think we can actually get rid of this float here. This notebook, just like all of our other notebooks, used to be written in Python 2. No, we can't, because if we look at the total production counts, no, that's not the problem. The problem is these, actually. So we encounter this error. This notebook, I suppose, is a little bit out of date. And the problem is that the data in the car by manufacturer dict, so the production values in the table broken out by manufacturer, are strings, and we'll need to convert those into numbers, just like we did for the revenue. So what we can do is say convert production. We'll call that prod. That'll accept some string s, and it's going to return, well, looking at these, we notice this number doesn't really need anything removed from it, but this one needs quite a lot. So we'll want to replace any commas with nothing. We want to remove all the commas. So we'll replace commas with the empty string. And then, let's see. We'll split on any spaces and return just the left-hand portion of whatever is returned by that split, the first element. And if we say for manufacturer in car by manufacturer, we convert the production and the last thing we notice is we forgot to cast the output as an integer. So we add that integer casting, and there we go. We've converted the production counts for all of the manufacturers into numbers. So we'll just add that here. And there's our answer. So Toyota has a market share of 10.5%. Volkswagen has a market share of 10.7%. But, you know, market share in automobiles, it might be looking at vehicle production is maybe a fair way to think of market share for automobile manufacturers. But what about petroleum producers? Well, we could try and look up the number of barrels they produce. But since some petroleum manufacturers maybe focus more on refining, while others focus more on drilling, I don't know what these energy conglomerates really do, but instead of analyzing based on kind of units of production, we'll look at their market share simply in terms of dollars. So if we look at these largest oil and gas producers, we can see their revenue for 2017 in billions of dollars. And again, we're just going to use pandas read HTML to retrieve that table we were just looking at. So once again, we see that our revenue comes back to us in as strings. So we'll again be doing a little bit of parsing to coerce those into numbers. But we're going to do a very similar thing as we did for the market share computation for the car manufacturers. We're going to compute the total revenue of all of these oil and gas companies. And we're going to compute the revenue for each company divided by that total to get an idea of their market share. So here we have the market shares of all the companies in that table that we were looking at. And we just want to extract the particular companies from this dictionary that are present in our Fortune 500 companies. That's these 5. And we notice once again, Some of these companies are present in our petroleum company dictionary, like Chinopec Group. So, but some of them are not. And looking through here, we see there's, for instance, China National Petroleum Corporation. And here we're looking for China National Petroleum. Now, we already knew that, some of our data might not be matched quite correctly. And in fact, this was one of the companies that we had seen was referred to one way in the Fortune 500 data and another way in the other data. So we could use this mapping once again to extract the market share that we just computed to join it to the Fortune 500 data. But let's do something a little bit more sophisticated, which is trying to compute a fuzzy match of this string to whatever might appear in the market share data. So say we didn't know that in the market share data, this company is called China National Petroleum Corporation. We only had China National Petroleum from our Fortune 500 data. How might we find a potential match for China National Petroleum? One thing we could imagine doing is, say, split this name up into separate words and check with each name in this data set how many matching words there are between the name we know and the names in this data set. And whichever company has the most matching words, we'll call that a match. And that's precisely what we do here. Our fuzzy match function accepts some word that we would like to match to some set of strings. We take our word, or name, and we split it on spaces and create a set. So we have now a set of words in our name. Then we compute the overlaps. How large is the intersection between our set of words and the names found in the other data set? So for each name, in our data set, we're going to compute the intersection of that name with the words of the name we're searching for. And then we simply return the name with the maximum overlap. So first we prepare our kind of set of names. So we have here, we're taking our shares, and for every key in that share, every name in the shares dictionary, we're again splitting it up by spaces and turning it into a set of words. We have a dictionary here keyed by the name itself, and then the value is that set of words in the name. And for each name in our petroleum companies, we're going to compute this fuzzy match function between the name from our Fortune 500 data and this set of names from the shares data. So we're able to find several matches. Chinopec Group matches Chinopec Group, not surprising there. China National Petroleum got matched to China National Petroleum Corporation because they have an overlap of 3 words, and that was the maximum overlap between China National Petroleum and any other name in the shares data. The other ones match exactly also. So now, if we wanted, we could join that market share data for the petroleum companies to the Fortune 500 data. For now, we're going to leave it at this, which is we've compiled market share statistics for our petroleum and automobile manufacturers. And again, we discover something kind of interesting. Even though the petroleum companies have higher revenue per employee than the automobile companies, we discovered that earlier, and they tend to be quite a bit larger, each one seems to have quite a bit less market share than the automobile manufacturers, which again agrees with our understanding that petroleum companies maybe just in general tend to be larger industrial operations than automobile manufacturer. In order for an automobile manufacturer to have a similar revenue generation to a petroleum company, it has to control a much larger market share than a petroleum company would. I'm going to wrap up this video here. In the next video, we'll quickly go through this analysis again, but working entirely within pandas.